today is going to be living in California because Graham's going to be coming to us just north of San Francisco. So a bit of his theme is talking about water, and here's a vintage pool, that skateboarder from the 70s. So that being said, I'm going to turn it over to Monty and Prudence. Let's kick it off. So off to you guys.
Thank you, Sean. Thank you, Sean. Good evening. My name is Monty Paulson. I lead the Passive House team at RDH Building Science. I'm happy to be healthy today. I'm happy to have a job in Passive House, and I'm really happy to spend the next hour with each of you. So please turn on your cameras. We want to see your face. Please turn down your microphones and close your email browser. It'll still be there an hour from now. And please join me in a toast to each and every one of you for another week of living, another week of working to make the built environment just a little bit better. Cheers.
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 Cheers also to Passive House Accelerator for hosting this weekly happy hour. We have a great lineup tonight. We have a video by Frank Crawford of Montgomery Passive House. Spoiler alert, this is the best 2-minute Passive House tour yet. Just watch how easy Frank makes this look. And then we have a fascinating presentation on how to design a system to reduce water consumption by Graham Irwin from, you guessed it, Marin County, California. Now, please allow me to introduce my co-host, Prudence Ferreira.
Welcome everyone to our 10th anniversary. This is the 10th Global Passive House Happy Hour. On behalf of the entire Passive House community, I'd like to give a special welcome to any newcomers. I'm Prudence Ferreira, and I've been making my living as a Passive House consultant and Passive House consultant instructor since 2009. I lead the Passive House team at Morrison Hurstfield, and I'm also, like Monty, really grateful to be able to say that even in these uncertain times, Passive House is still paying the bills. Thank God. Many of you joining have Passive House projects that you're working on or that you live in, if you're one of those lucky few. We want to see your walls. We want to see your windows and doors, your thresholds, your kitchen and laundry, if you've got those, if you're in a residential project. And more than anything, we want to see your mechanical room. So invite us over to get nerdy with you by making a 2 to 3 minute video so we can share inspiration and admire your excellent work and learn from your mistakes.
So this is Monty again. We want the Passive House Happy Hour to be a place that welcomes newcomers, as Prudence said, as well as a place for Passive House veterans to connect with one another. You will find we're an extraordinarily open source community. By that I mean, you'll get at least 2 divergent answers to any question you might ask, sometimes more. But while we may disagree on the details, we're here because we all agree on the basic principles that make buildings better. These include exemplary L-tightness, thick walls with continuous insulation, continuous ventilation with energy recovery, thermal bridge-free design and construction, high performance windows and doors, and let's not forget compact form factor. So see how many of these features you can spot in this short video about the Montgomery Passive House, which is just a short drive east of here on the Trans-Canada Highway in Calgary, Alberta.
Hello everyone, my name's Frank Crawford, and this is the Montgomery Passive House in Calgary, Alberta, Canada. My wife and I designed it. I acted as a general contractor and was on site every day to help build it, and we've been living in it for the past 4 years, since 2016. As far as Principle 1 insulation goes, I have R37 below the slab, 8 inches of EPS foam, as well as 8 inches EPS foam on the foundation walls for R37. Above grade, it's a split insulation using Roxol for about R40, 42. And the roofs are R60 fiberglass in the TGI joists. So here we are in the secondary basement suite of the Montgomery Passive House in the mechanical room. And behind me you see the principle number 5, the mechanical ventilation, which is done through an HRV, or in my case I have an energy recovery ventilator, a Zender unit, so I can recover both the heat and some of the moisture because Calgary is a very dry and cold climate. It has an electric preheater inside the machine, and up here you can see kind of it is a hydronic post-heat coil that provides some of the heat to the house. It brings the temperature from the HRV, which is about 16, up to about 20-21 degrees. And over here is the larger kitchen and that one west window that gets shade fabric in the summer. And then the other large thing is we have a pretty big 5-foot by 10-foot, that's the big heater for the house, and it's also the half of the bench for the dining table. Now we'll go upstairs to the open loft. So this is the open loft of our house. Instead of having more solar panels and get net zero, we went with some clear story upper windows. So again, they provide lots of light and a fair amount of heat to this upper open loft. Right now it's just an open loft for the kids to run around and leave their toys out, and we don't have to step on them. So here's the south side of the Montgomery Passive House. As you can see, a whole lot more windows than the north, and almost no windows on east and the west. The windows are a Passive House certified tilt and turn UPVC white frame. They're from Clear Wall or Munster Joinery. The names change in different countries. And that's about it. Thank you.
That was a great video.
Absolutely. Thank you, Frank. So I wanted to do a quick shout out to Building Energy Exchange for the multifamily passive house diagram that we showed earlier to you. We're going to pivot now to a quick rapid fire breakout room session. So we're going to split into rooms of about 4 to 6 people. And if you could, and we'll be in those rooms for about 3 minutes. So if you could just do a quick introduction of yourself so we can get to know one another. And here I need to set it up real fast. Create. All right, enjoy. That should be it. So I'm going to be, let me go through the announcements real fast. And I will also cut and paste this and put it into the chat so that you have the information. But NAPHN is holding a virtual building tour competition, and entries are due on May 29th. And there's a link there to get more information. International Passive House Open Days is going virtual this year, and the deadline for submissions is June 19th. Number 3, FIAS has moved its trainings online. The CPHC online portions starts on June 8th, and the CPHB for builder training starts June 2nd. Number 4, you have 2 days left to submit your proposal, speaking proposal for the 2020 New Gravity Housing Conference, which is a great conference put on by Green Building United. Number 5, we have the fine folks at Massachusetts Clean Energy Center who have been involved in one of the presentations here in the happy hour, do great work. They are doing a series of webinars. The first one that I want to share is tomorrow, and tomorrow at noon Eastern, Passive House verification. And then also tomorrow at 6 p.m. Eastern, the weekly BS for Building Science and Beer Show will be highlighting bio-based material and high-performance buildings. So don't miss that. And finally, I'd like to thank our sponsors, the founding sponsors who make our work possible: Mitsubishi Electric, Zola Windows, and RDH Building Science, as well as our patron sponsors, Morrison Hershfield and 475 High Performance Building Supply. Thanks. Well, I can,
no, I'm so sorry, you guys.
Okay.
I need the.
Oh, is it a boomer? Boomer?
Yes, it is.
You're on mute, Boomer.
I know.
oh, you just had your birthday.
Actually, it's less a boomer thing, and it's more having 30 windows open at the same time. too much going on my screen.
Quit working so hard.
I know. So I'm really honored to introduce our guest this evening, Graham Irwin. I've known Graham for as long as I've been doing Passive House, and he's one of the smartest guys I know. He's a Passive House pioneer in California, having consulted on the first certified Passive House in that state, which was also the first certified Passive House retrofit in all of the US. And we're not talking interfit here. We're talking all the way full compliance with what we call PHI Classic today. He also consulted on the first certified multifamily Passive House in the US. He really is, in the truest sense, a Passive House triple threat. He's got a degree in physics, an architectural practice called Essential Habitat, and he's a licensed contractor. His curiosity and idealism drive him to ferret out blind spots and leave no stone unturned in the quest for data and practical solutions. Now, whether you're new or an expert when it comes to Passive House, it's important to remember the Passive House is a fantastic stepping stone to low operational carbon emission buildings. And after we slash that space conditioning load, cooling and heating, with our super insulated airtight building envelopes with minimal thermal bridging, optimized window performance and placement, and balanced heat recovery ventilation, the next monster load is hot water, which has a huge impact on any Passive House project's ability to meet the primary energy limit for certification. So Graham is going to take us into his mind and into his home to look at energy associated with water and his clever no-nonsense strategies for minimizing it. Take it away, Graham.
Thank you, Prudence. And thank you to the organizers and everyone for attending. I will do my best to live up to that amazing introduction. And hopefully my slideshow will cooperate. There it goes. Okay. So thank you for tuning in. I'm going to talk about future-proofing for energy and water savings today. Everyone hear me okay? Yeah, I can hear someone else. So I'm the principal of Essential Habitat Architecture. I've been working in Passive House since 2008, mostly in California and mostly in the Bay Area. I've worked on maybe 30 projects. And I realized that they don't exist in a bubble. So that's kind of a long-winded way of me telling you that today I'm going to talk about a building that isn't even a Passive House. But the principles I'm going to discuss, I think, are very applicable, and the reasoning, sort of the thinking that I'm going to use on this is the same sort of thinking that I use to think through Passive House energy issues. So this is a picture from the 1940s of our Tuscan ruin. In addition to an architect, I am an amateur developer. And my wife and I purchased this building several years ago and set about to repair it. And people said, oh, hey, Graham, are you going to make a Passive House? And I said, eventually, but right now I just need to aim for Haus. So this thing was kind of falling over, and we kept the scope within our means and patched things up. But while we were doing it, we did some things that I think are really critical. And I think they're critical enough that I make them standard in all my plan sets. I don't even ask the client whether they want this stuff. It's just, it's included, and I'll explain why. So this is a pie chart of the site energy use of an average California household. And when I developed this maybe 10 years, 12 years ago, I was shocked. And I wasn't shocked by how low the heating energy is. So this is an average of all the households that exist across California. Because we do way better than this. You know, when we do our Passive Houses, we cut that way down, though we do have stiff competition and baseline in terms of making sure that things perform well. What really shocked me was that hot water was larger than heating. And this is just across the state. And so what that said to me was, if the hot water is not attended to, you're really leaving something behind. And furthermore, fixing the building shell is great, but if someone dealt with the hot water really well and didn't even bother with the trouble of Passive House, you might actually get to a lower energy use. So the trick is, I'm not suggesting not to do Passive House. Of course you do Passive House, but you have to do that hot water as well. And yes, this is looking at California with a mild climate, but I might argue that a lot of multifamily buildings elsewhere probably have this kind of, especially larger buildings have this kind of thing where the heating demand may not be the largest thing. And beyond that, most Passive Houses look kind of like this, where the hot water is the single biggest end use. So you can dial into this a little bit further and look at a pie chart that shows what uses of hot water there are and which ones are the greatest. And we see that showers are the largest typical in a house. And there's a really great passive solution for that. But before we get to that, again, with passive house, you want to start with efficiency first. So you want to use water efficient fixtures, cluster the fixtures together to shorten the pipes, insulate the hot water pipes, make sure all your pipes are in conditioned space. I know in places where pipes freeze, you guys avoid that, but here in California, it's often easier said than done, getting the pipes in conditioned space, but very important. And you want efficient water heating. So this is a device that many of you may be familiar with. It's a drain water heat recovery device, and it's similar to a heat exchanger in a ventilation system in that it extracts the heat from waste, in this case, wastewater leaving the building. And so there's basically a coil around the sewer pipe or the wastewater pipe, and as warm water is leaving, cold water is wrapped around the outside, and it basically takes the heat from that wastewater and transfers it to this water and warms that water. So you're again, like in passive house, recycling the heat inside. This diagram on the right, I really like the drawing, but it's kind of ridiculous because it does not work for tubs. This has to be happening simultaneously. So basically, you have to be using the hot water at the same time that you're sending hot water down the drain. And it works best if you plumb the warmed water or the tempered water both to the hot water tank on the cold side and to the shower valve. And so basically what happens is, as you begin taking your shower, ideally this shower valve should be a thermostatic valve, so it does this automatically, but what's called the cold water begins to warm up. The valve will automatically reduce the amount of hot water that it's drawing as the thing comes into equilibrium. You also want to send it into the cold water of the hot water tank because you don't want to be pulling cold water straight in. So this can save about 18% of shower energy, and incidentally, or interestingly, there's a lot of the studies on this are from Canada, and they talk about adding a 0.12 energy factor to the heating system, water heating system, in some modeling software as an approximation of what this does. So it's a great addition. California also has a history of drought, and Sean found this photo and I used it again. This, you think about skateboarding now, basically developed because we had droughts in the past and people couldn't keep their pools full. So there are all these empty pools that people could skateboard in, Dogtown, Sea Boys, and all the rest. But this is part of our existence, and so it's always in the back of my mind. Beyond that, though, water is equivalent to energy. The water that you get in your house doesn't just show up by magic. This, again, varies by location and circumstance. But in California, simply delivering water to buildings is 2% of the total energy that the state consumes. So it's significant. And so you want to be mindful not only about saving hot water energy, but saving water as well for energy uses as well, or energy aspects as well as just environmental aspects. So we can look at a pie chart of residential water use in California. And again, this varies. This is not every building, but this is kind of an average. And we see there's an enormous amount of water used outdoor. Inside, toilets and clothes washing together add up to a pretty significant chunk of the interior. So we'll look at some solutions to save water. Again, conservation first, water efficient fixtures, cluster the fixtures together, efficient and native landscaping. So in my area, a lawn requires about 3 feet of irrigation water per year over the entire thing to keep it alive. And a dirty secret is that there's very little grass in the US that was not originally brought over from England, even Kentucky bluegrass. And most of the climates in the US are very different from England. If it's not raining in England right now, it probably will be by the time this talk is over. So lawns are really a problem and very water thirsty. So it's really worth considering finding alternatives, and also permeable hardscapes, which will allow rainwater to just go right into the ground and recharge the aquifer. Using rainwater in our climate, we're in a Mediterranean climate, so it's a problem for irrigation because we have dry summers and wet winters, and that's the opposite of basically the water comes at the time we don't need it for irrigation, or you could, by conversely, you could say we need to irrigate because it doesn't rain in the summer. So rainwater, direct rainwater to landscape isn't really the killer app for us. Graywater is. And graywater is basically using all of the wastewater in your house except for kitchen sink and toilets. That water can be used for subsurface irrigation. And in fact, where I live, the water district now, if you do a major remodel of a house or build a new house, you are required to install a graywater system. Some of them are quite simple, but in any case, this is our solution for irrigation. And it also takes some of the burden off of the sewer system as well, which is also a benefit. Rainwater is useful, especially useful if you can use it indoors, because you can apply that water that's rushing by the house or going into storm drains and so forth to flush toilets and do cold water laundry. And you can also have a tank and store it to use in the summertime, but you get a much higher yield out of the system if you can use it during the time that the rain is falling, during the seasons the rain is falling. So interior use is really a good solution. There's an example of a project of ours from Santa Cruz. They put in a rainwater system, and their calculations are they save 6,000 to 8,500 gallons a year with interior. Lastly, structured plumbing. So this is basically a way of saving the water. You know how in a lot of people's houses, you go to take a shower and you turn on the shower and the water's cold. And so you stand back from the shower and you let that water run down the drain until it's warm enough to get in without shocking you. Well, that adds up to quite a lot of water waste. And so this is basically a system that has a hot water return line. So it will take all the water out of those pipes, send it back to the water heater, and fill the pipes with hot water before you turn the shower on. So rather than dumping all that perfectly good lukewarm water down the drain, it just goes back to the water heater. And the goal with these systems is to use less than 1 cup of water waiting for hot water at the fixtures. And calculations on this can save 3,600 to 12,000 gallons a year in a house, and about 800 to 1,600 kilowatt hours per year of energy, because the water that you're flushing down the drain is not cold water. That at coldest, that would be room temperature water. So keeping that in your water heating system rather than introducing cold water out of the ground also saves energy. And this improves comfort and convenience for homeowners. So this is a system diagram of our house, and it's actually 2 units. The top floor there, this is, again, I just stripped the plumbing fixtures out of the BIM model, but the top floor is a separate apartment, and then there's a 2-story apartment beneath. And this is, I'm just gonna quickly illustrate the approach that I took. So the first thing is black water, plumbing the black water to sewer. In the top apartment, the gray water as well is going to the sewer because that unit was actually occupied, and that sewer line goes in a different direction. And so that part did not get desegregated. But in any case, this is step 1 is plumbing, drains as usual. Step 2, collect the gray water. So I've got everything but kitchen sink and toilets and dishwashers, basically kitchen sink. Those are black water. Every other source of wastewater in the building is gray water, and it's all collected together and brought down through the house to a single pipe where it can be directed either to irrigate landscape or go to the sewer, such as in the wintertime when it's raining and you don't want to be there's no need for irrigation, and putting gray water in wet ground could have pollution issues. Third is the drain water heat recovery. And again, it's convenient if you're already collecting the gray water to just run the gray water through the drain water heat recovery device, which is this diagonal blue line. And I've got the blue line, water going around the gray water pipe and supplying the cold side of the shower in the master bathroom, and going to the cold side of the water heater. And lastly, plumbing the supplies to all the toilets and the cold side of the laundry with Rainwater-Ready plumbing. And it's basically purple PEX tubing. And I just do a home run system through the building and have it all ready. And so now this building is rainwater and graywater ready. And then final thing is the structured plumbing. And this is basically a hot water loop that runs around the building, gets very close to all the hot water using fixtures. And there's a pump here that pumps that on. There are buttons in each bathroom that you press when you're about ready to take a shower. The pump runs, pulls all the lukewarm water back into the hot water heater, fills the supply loop with hot water, and you turn on the shower and you don't have to flush a bunch of water down the drain. Here are some pictures inside the building. So this is on the left here, this is the kitchen wall. That's the drain water heat recovery device. And to the right of it, you can see some of the purple PEX tubes going upstairs into the, sorry, I just seemed to click without me doing anything. Going upstairs into the bathroom and laundry. And on the right is what it looks like all covered up, almost done with this project. Upstairs, you can see a PEX tube supplying water to the toilet, and a couple more running upstairs into the bathrooms above. One thing to note, if you're intending to have a bidet seat, you should really have that with potable water. By health code, you're not supposed to have human contact with rainwater unless it's been treated. So there's a separate little line here to supply essentially cold drinking water to run the bidet seat. Over here, bathroom almost finished. On the right, you can see the little button here. This is the button that will trigger the on-demand hot water recirculation, and the shower is behind us. Here's the laundry. Again, you can see the PEX tube running to the cold side. And on the right, the same finished out area. Here, there's basically a signal wire for the future so that you can turn the gray water on and off without having to go all the way down into the basement. And you do that seasonally. Obviously, during rainy season, you turn off the irrigation, but you might also, for instance, if someone were using bleach in their laundry, and we can debate whether you can debate that with someone else. I've given up debating that, but if you're using bleach, you don't want that going into your garden, so you could flip that off for the duration of that wash. And downstairs in the lower bathroom, again, you can see PEX for the toilet. You can see a separate line here for bidet seat, and again, the trigger for the on-demand hot water. And this is basically what it looks like: low flush toilet, dual flush, on-demand hot water recirculation, and rainwater plumbing to the toilets. Underneath the building, you can see this is where the two pipes come together. This line is black water from the toilet and the kitchen sink coming in here. This is all the gray water in the house, and I purposely left this long piece of pipe here so that when we implement a gray water system, we can just take that pipe out and install a diversion valve like this one. This is a pool valve that's often used for gray water systems, and it's got an electric actuator. And right up here, this is the wire, the trigger wire from up in the laundry that could be used to trigger that. Collecting rainwater. So on the side here, you see this pipe coming down. I basically collected all of the roof water that was previously undermining all the foundations and whatnot, got it all into one pipe, comes down here, goes underground, and right now spills down under this deck. But this deck would be a great place to have a water storage tank. So that's the idea in the future, is got all the rainwater being collected and it can be stored right there. And then, as I told you earlier, we've got this PEX home run system supplying, at this point it's connected to city water, but I've got one to each of the toilets and one to each of the laundry. In the future, that can be disconnected and set up to use a rainwater supply. And that is the end of the story. I told you it was a Tuscan ruin. When we're feeling more optimistic, we also call it Villa Fortunata. But in any case, thank you for your time. And I
Graham, thank you.
End screen sharing somehow. Should I stop share? Yes.
There we go.
Yes.
Okay.
Thank you, Graham.
You're still sharing your desktop with us, though. There we go.
Which is just as
That
interesting.
just took time. That is a mess, isn't it?
Sean, do you have some questions queued up
I
for Graham?
do. Sorry, I was just trying to get it lined up. The one comment, Graham, Ben asked, was that vintage photo that I have behind me, is that you as a kid?
It is not, though. And my hair, well, it's not going to be that color, but it's getting closer and closer to that length.
Jeffrey X, you had a question. We'll kick it off for you as I scroll up to the first questions, because I got 3 pages worth, so we got a lot to go through tonight. So Jeffrey X, do you want to pop on, or I'll wait?
Yeah, sure. I had a lot of questions. Which one was it?
Yeah, ask the first one. And it was, is solar hot water scaled down to a single family yet? And you had a couple other points on that. So,
well, solar hot water and also solar cooling. There's something I've been, looking into. I'm just curious. I know solar hot water can be scaled. It depends on your region, how well it does and stuff like that. Pretty simple stuff, preheating. I'm also interested in solar cooling. If that's been scaled down, that's a little bit more, I imagine more expensive.
Yeah, there's an ongoing debate, and too broad to get into here, but a question of whether one should do solar thermal water heating or solar photovoltaic and power a heat pump with it, and there are arguments on both sides of that. The solar cooling thing, I haven't heard of it being scaled effectively to single family at this point. But again, there could be the other argument of photovoltaics powering heat pump or air conditioning as well.
all right, Hank, do you want to come on and ask your question? Hank had a question about on-demand water systems.
He went to grab a beer.
Yeah, it happens. Good choice. Sorry, Graham. Yeah. What about on-demand water systems? Did you consider that?
What does that mean? An on-demand water heater?
Yeah.
Yeah, we'll actually have one. Right now we have an on-demand electric water heater.
Okay.
Yeah. And another whole topic, but it will either eventually be the backup for a solar thermal system, or it will be replaced with a heat pump water heater.
Okay. Stephanie had a question about pollutants. I think it might have been answered in the queue, but I'll just get her to ask it.
Before we continue on, why wouldn't you use it as a preheated? Just out of curiosity, does it end up too high, too hot?
What's that?
Solar hot water to preheat the on-demand system. Does it end up too hot, or that's kind of what I?
No, I would use solar hot water to preheat the on-demand system. That would the on-demand system would be the backup for when the solar hot water isn't sufficient. Yeah, and electric on-demand plays much better with solar thermal than gas because it modulates a lot better. But again, we don't want to get too deep in those weeds right now.
Okay.
Very cool. Thank you.
Scott Kennedy, you had a couple of questions, and then Andrew Peel's next.
One question was just when you put the timer on your recirc system, do they just like run for 60 seconds and then stop or something like that?
It's a thermostatic control. So the pump's checking the temperature of the water coming back from the loop. and when it reaches temperature, it turns off. You basically press the button when you're about to use the shower, and the pump says, okay, I'll pump now, and then, oh, it's warm enough, I'll stop.
Okay, thanks. I think that was my main question.
Okay, Andrew Peel.
Hi, Graham. I was wondering, have you taken into account the losses from the recirculation line in that energy calc you did about how many kilowatt hours it saved per year?
Well, I didn't do that calc. I just stole it from an LBNL study. So I can send that to you if you want to dive into it.
Probably not, but it'd be interesting to know.
Yeah, it would be. And I can even you could probably just email the guy to ask. I think that, the pipes are insulated, and it would vary by location and so forth, but it doesn't get used a ton during the day. So hopefully not too much energy loss with that.
Audrey?
Okay, so I'm new to this whole passive house thing. I'm amazed by how everybody's brains work. I'm in modular construction, but I'm fascinated by your conversation. And I'm sorry if this sounds ignorant, but do you have to have a special, so you're already putting your plans together. Do you have to have a special plumber understand all of this information to be able to put it into these building systems?
That's an excellent question. I don't think it's ignorant at all. I think passive house in general requires extra care and attention from the people building it, and this stuff would qualify as well, although I'd say it's not super complicated to do for plumbing. The thing about it, and the reason that I just put it in all my plans, is it seems very easy to do at the time, but very hard to do later. So I'm just, again, someone hires me to design their passive house, they get this stuff in the plans, whether they ask for it or not. But most plumbers, it's not standard practice for them, but it's not that hard for them to do it when they're reminded of how and why.
It's fantastic. Thank you.
Thank you.
I was just curious about the cost for some of these recirculation systems. I think it's wonderful. We've talked about it in the past, but always seems to get BE'd out. So just curious if it's becoming less expensive, or if, as you say, if you just start from the beginning, it just gets in there automatically.
Well, good question as well. I would say in our particular circumstance, I was nervous about using PEX, and I instead I used copper. I've been cured of that nervousness because of how much labor and cost there was. In terms of the plumbing cost, it's not very high, and the pump is $500 maybe, something like that. So again, you can VE out anything, but there's a lot of value in this thing, and it also you don't want to make an argument for that. You can say, hey, when you take a shower and you sit in there and you like freeze for a while, no more, instant, right there all the time. Just hit this button and away you go.
Great stuff. And Kate had her hand up, so I don't know what her question is, but Kate, do you want to ask your question?
Can you hear me?
Yeah.
So I'm just curious, if you were going to prioritize based on budget, because I have a really tight budget, as most of us do anyway, but what do you think would your priority be, like, regarding the energy water questions? What would, if you had money to put into something and it was number one, like, what would it be, the actually accessing that Graywater potential? Or I'm just curious, looking at all the options, and you have a lot of bells and whistles going on, but if you had a limited budget, what would prioritizing it, what would that look like?
Well, again, like this, yeah, great question. Like the slide I had, I would start with efficiency. So I would get efficient fixtures, shower heads and things like that are efficient, even if they were a bit more expensive, before I did any of that other stuff. And again, the Graywater and Rainwater is very specific to your circumstance and your location, and you'd have to evaluate those sorts of things. And some of this is about hot water, and some of it's about water savings in general. But
would you prioritize Graywater over? I know I wrote down your first thing was obviously fixtures, and I would do that anyway. So I kind of almost don't, that's like a non-issue, but the gray water, you think before you go to the extent of like that, you know, I like that idea of not wasting water as you're waiting for it to turn hot. But would you say gray water, because I wrote down again, 66% of it in your house is gray? Would it make more sense to try to utilize that than worry about hot water down the drain?
You mean in terms of the drain water heat recovery versus the pump? I think I probably would do that first. Yeah, I just think, you know, you put that's about that drain water heat recovery thing is maybe the big one, the biggest one's like $800 where we are from Home Depot. You put that thing in and it just works forever, you know, and it saves a lot of hot water that way. So yeah, I would probably do that first before I worry about the pump thing.
Wonderful.
Yeah.
Thank you.
All right, the next one, Adam Martin.
And I'm on mute. not anymore. Graham, you mentioned having this water system being a key feature, almost a non-negotiable for your construction project. I'm curious about the other non-negotiable or the items that you always like to have installed in your properties.
Well, so we do passive house, so that's you know, that's basically where we start. I have some non-passive house remodels and things like that, but that's what we do. So people come to us and they come to us wanting passive house, or they come to us unsure, and then they go away and decide if they want it, and if they want it, then we work with them. So yeah.
Okay. Thank you.
Sure.
Okay, Damien, you can come on, and you can only ask 2 questions because you have 5 in the queue here. So just ask 2.
Okay, the diagram showed that bath water goes into the black selection, often shown in Australia as going into the grey collection. Is that a legislative thing, or?
No, so that was in this particular project for the upper unit, because it was occupied and those drains went. It's complicated, but one sewer goes out to one street and the other one goes down. So I would have put that into the Graywater system, but I didn't touch that plumbing. So cool. Yeah, no, everything but toilets and kitchen sink is Graywater. Yeah, and I will add, Australians know a thing or two about Drought and Graywater and Rainwater solutions. My hat's off to you about that.
Yeah, it was amazing. It was amazing saying that, you know, we have a big glowing sign up down the street from us, current consumption at 180 litres a day per person. And, you know, I was seeing the California numbers that you were putting up and they were horrific.
Yeah, and again, ours isn't that high. We don't have lawn, but I mean, you know, more than half the water for irrigation and most of that for lawns. So again, it's kind of ironic that we fight for the American God-given right to grow British grass, but maybe we can get over it.
All right, Lucio, you had a question about Sandins? Oh, I think Lucio's having too much fun texting in the sidebar. Oh, there you are. Yeah, we can hear you.
I think Andrew and Scott have addressed it, but my question was, when installing the coil with the Sandin heat pump, we've been told by Sandin that they don't recommend this as it affects the efficiency of their system. Any comments on that?
I imagine it might well reduce the efficiency of their system because a bigger delta T, or the colder the water coming in is, the more efficient it will be. That's probably true. Whether that outweighs the overall benefit,
Yeah, it's hard to say. And my feeling is that it's such an inexpensive system that we just use it as standard on all our builds now and make sure, you know, it all works in unison.
I would also be surprised, but I'm open to it, that a passive solution like that would be less efficient than the heat pump.
Right.
You know, working at outdoor temperature water, but again, you know,
hard to say. Yeah.
I mean, for that matter, passive house, ventilation system makes the heat pump that might condition the space heating less efficient than if it were colder. But you know, we swallow those lumps too because it's overall a better situation.
Exactly.
Thanks, guys. Enrique from Vermont.
Yeah. Hi. Thank you. Hi, Graham.
Hey.
Good seeing you again.
You too.
I'm working on a residential development in the Caribbean for a single-family duplex, and we're thinking about having a collection system for rainwater to be used both in toilets and as well as the irrigation system for the landscape. Is there any better system that you have been experiencing with, or I mean, tank-wise, or what, or just collecting it from the roofs and putting it into a centralized tank, or what?
Yeah, I mean, you basically want to collect it and put it in a centralized tank, and then what use you put it to depends on how much effort you want to make. So if you're, at least where we are, if you're not going to sterilize that water, you can use it for irrigation, you can use it to flush toilets, you can use it for cold water laundry. There are of course systems that will treat that water and make it drinking water, and then you can use it in other cases. But I worry a little bit about how energy intensive that is.
But even for toilets, you will require some filtration system or not?
You just have a filtration system kind of on the downspout, like it's called the first flush, that just makes sure, like if it's been a long time since a rain, the first bit of water that comes down the downspout gets thrown away, so you're not washing like leaves and bird crap and stuff like that into your tank. But it's you just filter for silt, and that's it. And then you have to pressurize it, obviously, to use it inside, but it's pretty simple.
So with like a constant pressure system to pump it back into the.
Yeah.
Okay.
Yeah, there's that website. I had a logo there. There's a thing called Graywater Action, which is a really good website, and it has information both about graywater and rainwater. But that's a great thing to look at. There's some stuff from the state of Texas, and of course, a ton of stuff from Australia on this as well. So there's a lot of information out there.
Okay, thank you, Graham. Good seeing you.
Yeah, you too.
Thanks.
All right, and Ben is up next.
Hi, Graham. Thanks for that presentation. That was great. My question is really around recirculation, the recirculation pump, and whether you looked into whether there was any penalty to having the recirculation and the pump running in terms of heat losses to the building in the cooling period, and whether it still outweighed the effect that had.
Well, so I guess the thing about this, the pump only runs when you're about to use it. You know, there are systems in multifamily buildings, and for that matter in single family buildings, where they have the pump running all the time and keeping the hot water hot all the time. That would have I could see that having a much larger energy penalty. Even if you got rid of the pump completely, those pipes are still going to end up with hot water in them. It's just that before they have hot water in them, it's just about the water that's in there right now, that lukewarm water. Is that going back to the water heater, or is it going down the sewer? That's really the only difference. You're going to wind up charging all those pipes with hot water regardless. So I don't think there's a big difference that way, at least to my, off the top of my head.
Yeah, I guess, sure. Yep, no, that's good. Thank you.
Do we have any idea on like user compliance on this, of running the circulation pumps at the right time, and in a rental or multifamily or something like that?
I think it could be kind of a Pavlovian thing, right? Like, you want to freeze, don't hit the button. You want to be warm, press the button. I don't know. People, I haven't seen studies on it. I don't know. I'm certainly going to use it, and I suspect that the rest of my household will be trained sooner or later.
Ray had a question, but I think it was similar to Ben's. Ray Clemens, did you want to ask anything else, or did Graham answer the question you had?
No, that was the exact same question about the energy penalty for the on-demand recirc pump. So thanks.
Yeah, and the recirc pump thing is mostly a water savings more than an energy savings thing, but it has both benefits.
David Hortzclaw had a question.
Yeah, quick question. In my neck of the woods, our municipalities frown on graywater use and rainwater use. So lots of areas that's against code. Any recommendations on how to get around that? And have you done any water quality testing just to verify your results?
Well, so again, what I've done is Graywater and Rainwater-Ready, and I won't say that a building inspector won't tell you that you can't use purple pipe to plumb your toilets with, right? Or that you must combine the sewer pipes together up in the bathroom. So, you know, it's a question of whether that will forever be illegal, and I tend to doubt it. And also whether, like, and I'm not advocating you do things without permits, certainly would never do that as an architect, but you know, after the fact, who knows what happens. And you were asking about water quality in what regard?
Just confirm some, like, you know, you're not getting biological growth in some of those gray waters that's bleeding over into other pipes, just to verify water safety. This is sometimes an issue in commercial buildings.
That the gray water is mixing with supply?
Correct, yeah.
Yeah, I guess that would have to be out. That would have to be outside, and it might be. I don't know how that would happen.
Is your hot water? What temperature do you keep your hot water at?
Mine personally, 120 Fahrenheit, whatever that. I don't know what that is in Celsius.
But. We'll get someone to do a quick conversion pretty quick. Thanks everyone for the questions.
Celsius, you have to have it above that to kill the bacteria, so that'd be 125.
Great, thanks Dale. Zach, do you want to come on and? Perfect.
I sure do. Rand, we'll have more time for questions in the after hour. I just want to let everybody know that we have a very exciting speaker for who's going to join us next week, Kate Nason. She is a pioneer of Australian Passive House. She's a board member of Australian Passive House Association, an architect for many small and large scale passive house projects, and is currently with the environmental engineering firm Atelier 10. And she will be presenting next week. So please join us.
Monty and Prudence, you want to say good night?
I just want to say thank you. Thank you very much to Frank for that great video. Thank you to Graham for a really fascinating presentation. And it's great to see everybody here on yet another Wednesday afternoon.
You took the words right out of my mouth, Monty. Ditto. I hope that bunches of you stay for the after hour. I'm sure we'll continue to have fun. And if not, we will see you next week, same time, same place.
Thank you, guys.
Thanks, Graham. Again, we'll get him answering more questions in a few minutes. So if you do have to leave, again, we will let you go. Again, this is it's been amazing that we've all been able to come together, the 10th Passive House happy hour. So again, thanks for coming.